Look at that. For all of human history, this has been our entire world, our blue marble, our one and only home. And for just as long, we've stared up at those pinpricks of light and asked ourselves a question. Are we alone? Is this all there is? For centuries, that question was pure speculation. But what if I told you that question has fundamentally changed? It's moved from the realm of wonder into the realm of data, of genuine discovery. Our galaxy is teeming with worlds, a vast cosmic ocean. And among them, a few special ones stand out. Worlds that make us lean forward and ask, could it be? This specific journey is about one of those worlds, a planet so intriguing, so Earth-like, that NASA itself nicknamed it Earth's cousin, because the evidence points to two possible futures. One is a vision of a lush, inhabited paradise. The other is a nightmare scenario, a hell's cape. So, if you're ready to embark on a journey 1,800 light years away to a world that might be the closest thing to a twin we've ever found, then join me. Every great discovery begins with a crazy idea. And in 2009, NASA had a truly audacious one. Instead, it would stare, unblinkingly, at a single patch of darkness near the constellations Cygnus and Lyra. This was the Kepler Space Telescope, and its story is the story of how we found a new world. This is the transit method. A planet passes in front of its star, and from our vantage point, the star winks. Imagine you're in a pitch-black room, staring at a single, powerful car headlight from 10 miles away. Now, a gnat flies directly across. We're talking a brightness drop of just 0.0084%. For 4 years, Kepler did nothing but watch and record. It generated mountains of data. But here's the catch. Not every dip is a planet, and one signal was particularly intriguing. A star, later named Kepler-452, was winking every 385 days. They used a technique called speckle imaging, a way to cancel out the blur of our atmosphere. They calculated the statistical probability, and the result? It was virtually impossible. The signal was real, and in July 2015, the world met Kepler-452b. Most of those earlier planets orbited small, angry red dwarfs. But Kepler-452b, it orbits a G-type star, a twin of our sun. This was the milestone. This was the moment it became real. And that is a story for our next chapter. So we found it, a world orbiting a sun-like star, right in the Goldilocks zone. This is where we become cosmic detectives. We can't go there. We can't even see it directly. All we have is a shadow and a wink. Meet Kepler-452. At first glance, it's a twin of our sun, but it has one critical difference. It's older. If our sun is a sprightly 45-year-old, Kepler-452 is a seasoned 60-year-old. This star is about 20% brighter than our sun, and that changes everything for its planets. This places it in the habitable zone, but it's sitting on the warmer end of the bench. Now, let's meet the star of the show, Kepler-452b itself. We call it a super-Earth. It's 1.6 times wider than Earth. That means this planet has roughly 4 times the volume of Earth. That mass gives it a surface gravity about twice what we experience. You'd feel like you were carrying another entire you on your back. This intense gravity would shape the entire planet. Think flatter mountain ranges, deeper ocean trenches, and a much thicker atmosphere. This single planet could have had 2 utterly different futures. It is the ultimate cosmic cliffhanger. Imagine it. A world with a 385-day year, seasons, liquid water oceans under an orangish sky. If life began here, it could be so advanced we might not even recognize it. But now, let's look at scenario 2, the pressure cooker. The runaway greenhouse hypothesis. It's a vicious cycle with no breaks. The oceans would literally boil away entirely. Kepler-452b wouldn't be Earth's cousin. It would be a twin of Venus. So which is it? A paradise teeming with life older than imagination? Or a barren, scorching hell's cape? The answer lies with next-generation telescopes, the James Webb, and its future successors. For now, Kepler-452b remains the ultimate question mark, a reminder that in the cosmos, the line between heaven and hell is terrifyingly thin. We began this journey with a simple, profound question. Are we alone? This isn't just a story about a planet 1,800 light-years away. This is a story about us. Kepler-452b isn't just a data point. It's a benchmark. It's the perfect test case. Kepler proved we could find them. TESS is scanning the entire sky. JWST is learning to analyze alien atmospheres. The ultimate goal? A habitable worlds observatory. For centuries, we thought we were the center of everything. Kepler-452b shatters that idea. The galaxy must be filled with billions of such worlds. Let that number wash over you. Billions. This is the Fermi Paradox. If life is so probable, why is the universe so silent? The next great leap is atmospheric characterization. But yes, it makes you dream about visiting 1,800 light-years. With our current technology, a journey that would take tens of millions of years. So what is Kepler-452b in the end? It is more than a planet. It is a symbol. It is the period that ends the old sentence, "We are alone," and it is the capital letter that begins the new, "We are not alone." So what are we going to do about it? It is a beacon of inspiration, a reminder that the universe is not empty. It is full of possibilities. The journey to understand it is just beginning, and it is a journey that will define us for generations to come.